Okay, today we will discuss question paper of JEE Mains 2016 in chemistry. As you know that there are total 30 questions in chemistry, and out of 30 questions, if we just little bit analyze, if we consider section wise, inorganic, physical, organic and other parts, okay. So in inorganic chemistry basically we include periodic classification, chemical bonding, S block, hydrogen, P block, D and F block elements, coordination compounds, metallurgy and inorganic salt analysis. All these topics are included in inorganic chemistry. And physical chemistry, you know that all other chapters of physical chemistry are very easy to identify. And in organic chemistry, we also include polymers, biomolecules, and qualitative analysis of organic compounds that you did in class 11th. And others includes environmental chemistry, chemistry in everyday life. These topics are included in other parts, and some questions based on practicals involved in chemistry. So out of 30 questions, there are total 9 questions from inorganic chemistry, 10 questions from physical chemistry, and 8 questions from organic chemistry, and 3 questions are from other parts. As you know that chemistry is very scoring part. If we just consider the cutoff of JEE Mains 2016, it was 100 for general categories and lesser than 100 for other categories. So it's very easy to score 100 marks keeping in mind the chemistry part. So somebody can score even 90 or above 90 in chemistry. So there is a question based on every topic, like there is one question based on hydrogen, properties of water, one question based on environmental chemistry, one question based on electrochemistry, one question based on coordination compound, one question based on states of matter, then again a question from thermochemistry, a question from gas eudiometry, that was wrong questions with wrong options, questions from chemical kinetics, questions from again D block, question from chemical bonding based on hybridization, question from biomolecule based on amino acids, questions from P block group 15 based on oxo acids of phosphorus. These are very important part. And questions based on qualitative analysis of organic compound, that is separation technique, questions based on metallurgy, questions based on periodic classification, questions based on nitrogen containing organic compound. There is very important reaction in nitrogen containing organic compounds, that is Hoffman bromamide reaction. So this reaction is very important. So many questions are based on these reactions which have already been asked in past years. Questions from solid state, questions from polymer, questions from halogen containing organic compounds, questions from atomic structure, questions from liquid solutions, questions from oxygen containing organic compounds, questions from chemistry involved in practicals, that is other part, questions again from P block group 15, and questions from chemistry in everyday life based on detergent, questions from hydrocarbon, and questions from surface chemistry, questions from S block element based on oxides of alkali metals, and questions from chemical equilibrium, and questions based on isomerism. That was an out of syllabus question, that is question based on R and S system of nomenclature of optical isomerism. So if we again go through this cutup, and if we just analyze how many questions are from class 11th and how many questions are from syllabus of class 12th, so the weightage is more for class 12th. 13 questions are from syllabus of class 11 and 17 questions are from syllabus of class 12. So more weightage is on topic of class 12. So it's just analysis. Now let's start discussion of questions. Now the first question is, the question is on your screen. So a stream of electrons from a heated filament was passed between two charged plates kept at a potential difference VESU. If E and M are charge and mass of an electron respectively, then the value of H upon lambda, where lambda is the wavelength associated with electron wave and is given by. So basically we have to find the ratio of Planck's constant and de Broglie's wavelength. So you know that de Broglie's wavelength is given by lambda is equals to H upon mv, and we also know that kinetic energy is equals to half mv square. So if we put the value of this velocity in this expression, then this de Broglie's wavelength expression will become h upon under root 2m ke. Now for charged particle, kinetic energy can also be represented in terms of its potential. In terms of its potential difference. So potential difference is given as a V. So we can say kinetic energy is equals to E V naught, just to differentiate this V from this. This is a potential difference. So if we place the value of here, so the expression of de Broglie's wavelength also becomes 2m EV naught. So this potential is an electrostatic unit, and E is the electronic charge in electrostatic unit. So just we can represent this expression will become H upon mv. So we have to find out the value of H upon lambda. H upon lambda will become under root 2m E V naught H per the expression. So I have placed V naught instead of V, as is in question it is given as V. So the expression become under root 2m E V. So correct option for this question is 3. So we will grade this question as an easy question because it is directly formula based question. No much efforts are required. And it is from structure of atom, and it is based on concept of dual nature of matter. So also I will advise you to make a list of concepts. So like you just take a paper and note down questions based on de Broglie's wave, or questions based on concept of dual nature. So it will become easier for you to revise the concepts. So next move to the question number 2. Now question number 2 is from organic chemistry. In this question we have to identify what will form if 2-methyl pentane is reacted with sodium methoxide in methanol. So 2-methyl pentane. Now this is 2-methyl pentane. 2-methyl pentane, and this 2-methyl pentane is treated with sodium methoxide. In methanol. So sodium methoxide is CS3ONa, and this is methanol. So we know that sodium methoxide is very strong base, as well as nucleophile. Very strong base and nucleophile. And this is an alkyl halide. So alkyl halide can undergo elimination reaction when come in contact with a strong base, as well as substitution reaction when come in contact with a nucleophile. So it is a 3-degree alkyl halide. So more chances of elimination and less chances of substitution, but there is a possibility of substitution also. So we can say during elimination what happened, one of the hydrogen from beta position will be eliminated along with H. So as a elimination product we can say we will get this one and this one. So these two elimination products, and it is a 3-degree alkyl halide, so substitution product is OCS3. So these 3 products are possible in this reaction. So the compound mentioned in option A is also possible, compound mentioned in option B is also possible, compound mentioned in option C is also possible. So we will say all these 3 products can form in this reaction. So correct answer for this question is 4. So this question is based on your knowledge of mechanism of substitution reaction, and it is an again little bit difficult questions, little bit. So we will rank it as a moderate level of difficulty, because you have to take decision whether you will get only elimination product or substitution product or both type of. So that understanding is required in this question. Now come to the question number 3. Now question number 3 is from solid state, and it is based on knowledge. If you don't have knowledge, what do you mean by metallic substances and ferromagnetic substances, you can't attempt this question. So in this question, which of the following compound is metallic and ferromagnetic? Lot of transition metal oxides are ferromagnetic due to the presence of unpaired electrons, and lot of transition metal oxides also behave like metals. They show metallic properties. So in this question, again, as I told you, this is based on knowledge. If you don't have knowledge, it's a, we can say, fact. So you must read your textbook properly. Each and every sentence, each and every word, each and every information is very, very important for examination point of view. So for question number 3, we will say the correct answer is 1. CrO2 is a metallic as well as ferromagnetic substance. You can found this statement in your NCERT textbook class 12th, part 1, page number 27 and 28, solid state, page number 27, 28. This exact line is mentioned that CrO2 is metallic as well as ferromagnetic substance. So it is based on knowledge. So question number 4, we will rank it as a difficult questions, because if you know this fact, then it is very easy for you, otherwise it is very difficult for you. Now next come to the question number 4. Right, question number 4, which of the following statements about low density polythene is false? Now be careful, we have to identify the false statement. Now to identify the false statement, first of all we have to think what are the important characteristic properties of low density polythene. You know that low density polythene is formed by polymerization of ethene, and after polymerization of ethene there will not be any multiple bond or delocalization of electrons, so it is a poor conductor of electricity. This is the correct statement. Second says its synthesis require dioxygen or a peroxide initiator as a catalyst. Yes, because ethene undergoes addition polymerization, free radical addition polymerization, and to initiate this free radical addition polymerization we need a free radical initiator, so that can be oxygen or a peroxide. So statement 2 is also correct. And statement 3 says it is used in the manufacture of buckets, dustbins, etc. Now again it is based on knowledge. You just can't say by looking or that it will be used for manufacture of buckets and dustbin. In fact, there are two type of polythenes, high density polythene and low density polythene. This high density polythene is used for the manufacture of buckets and dustbins, not low density polythene. Low density polythene is basically not used for manufacture of buckets and dustbin, and for the synthesis of low density polythene high pressure is required. Very high pressure is required for low density polythene, that is around 1000 to 2000 atmospheric pressure is required. So again we can say this question is based on knowledge. So if you have knowledge of characteristic properties of low density polythene, you can attempt it, otherwise it will be very difficult for you. So for question number 4, correct answer is 3. It is used in the manufacture of dust buckets and dustbin, which is a false statement for low density polythene. Next come to the question number 5. Now this question is from surface chemistry. It's an easy question, direct formula based question. For a linear plot of log x by m versus log p in Freundlich adsorption isotherm, which of the following statements is correct? K and n are constants. Now you know that for Freundlich adsorption isotherm we use equation x by m is equals to k into p to the power 1 by n. Now if we represent this equation in terms of log, then it will be log x by m is equals to log k plus 1 by n log of p. So it's an equation of straight line. If we plot a curve between log of x by m, then we will get a straight line having slope 1 by n and intercept equals to y is equals to mx plus c type equation. So the slope is 1 by n and intercept is log of k. So we have to identify the correct statement. 1 by n appears as the intercept, so it is wrong statement. Only 1 by n appears as the slope. This is the correct statement. 1 by n appears as the slope. So for question number 5, answer 2 is the correct. So it's an easy question, formula based question. You must remember these formulas so that you will be able to answer your question in exam. Next come to the question number 6. Now in question number 6, heat of combustion of carbon and carbon monoxides are given, and we have to find out the heat of formation of carbon monoxide per mole. So it is from thermochemistry. So again we can say just we have to frame two equations, one that represent the heat of combustion of carbon and other one represent the heat of combustion of carbon monoxide. Let it be delta H1 and its value is minus 393.5 kilojoule per mole, and second is the enthalpy of combustion of carbon monoxide. So carbon monoxide on combustion will form carbon dioxide, and it be delta H2 and its value is minus 283.5 kilojoule per mole. And then we have to find out the enthalpy of formation of carbon monoxide. Enthalpy of formation of carbon monoxide. So it is C solid. So obviously this C will be the C solid plus half O2 to gives CO, and this is delta H3 that we have to identify. So to obtain this equation, what we have to do, we have to subtract equation 2 from equation 1. We have to subtract equation 2 from equation 1. So our answer will be minus 393.5 minus 283.5. So obviously the answer will be in negative. So we can rule out 1 and 4 as the answer because these are the two positive values. So our answer will be negative. So after analysis, it's very easy. We can say answer is 110 minus 110.5. So option third is the correct answers for this question. So it's very easy questions. Next come to the question number 7. Now again this question number 7 is knowledge based question, and it is related to the practicals involved in chemistry. Something related with the flame will be given in your lab manual. So it is from lab manual. Now the structure of flame is given. 4 regions are mentioned in the flame. The hottest region of Bunsen flame shown in the figure below is. We have to identify the hottest region. So there is no actual concept. We have to study the various parts of flame, then only we can answer this type of questions. So it's again fact based. So the reason 2 is the hottest region of this flame. Reason 2 is the hottest region of this flame. If you don't have knowledge of this type, just you leave these questions. Instead of just making any guess, you just leave this question. So this is question number 7. So thus I will rank this question as a difficult question, because if I don't have knowledge of the various regions of flame, then I can't answer these questions. So any question that we are not able to answer is a very difficult question for us. Next come to the question number 8. Now in question number 8, we have to identify which of the following is an anionic detergent. Anionic detergent. Now see, its question is again from chemistry involved in everyday life. Anionic detergents. You know that anionic detergents or cationic detergents contain an ionic salt, and that ionic salt have a cationic part and anionic part. In anionic detergent, the anionic part is a long hydrocarbon chain part attached with some anion. So just we have to identify like RSO3 minus Na plus type compounds are used for anionic detergent. So let's say it should be some sodium containing compound. So option 1 clearly says sodium lauryl sulfate is an anionic detergent. Citryl trimethyl ammonium bromide is a cationic detergent because its cationic part contains long hydrocarbon chain. And sodium stearate is a soap, not detergent. Sodium stearate is a soap, not a detergent. And glycerol oleate is used for the preparation of sodium soap. So that's why best answer for this question is option A, sodium lauryl sulfate. So it's an easy question. Next come to the question number 9. Question number 9 is from liquid solution chapter. Now this question says 18 gram glucose is added to 178.2 gram water. The vapor pressure of water in torr for this aqueous solution is. We have to identify the vapor pressure of an aqueous solution. Now to identify vapor pressure of an aqueous solution, just we can visualize. We have pure water having some vapor pressure P0, and this is glucose solution having some vapor pressure Ps. So according to the principle of lowering in vapor pressure, P0 minus Ps upon P0 is equals to N upon N plus N, where N are the number of moles of solute particle and capital N represents the number of moles of solvent particle. Now on rearrangement, this equation can be rearranged to P0 minus Ps by Ps equals to N upon N. On rearrangement, we will get this equation. P0 minus Ps by Ps, N upon N, and it can be represented by mass of glucose upon molar mass of glucose, upon molar mass of glucose. So let's say if we substitute the data directly, mass of glucose is 18 gram and molar mass of glucose, let's say something m, into mass of water is 178.2 and molar mass of water is 18. So this is the equation. Molar mass of glucose is 180. Now we have to identify the value of Ps. To get the value of Ps, you should know the value of P0. Otherwise, you can't solve this equation. And nothing is mentioned about the vapor pressure of pure water. You know that vapor pressure of liquid depends on temperature. So here we have to make an assumption. Let's say this situation is given at 100 degrees Celsius. If this situation is given at 100 degrees Celsius, then we can say vapor pressure of pure water will be 1 atmospheric pressure, that is 760 torr. We have to identify the answer in torr. So this equation will become 760 minus Ps upon Ps equals to 18 into 18 by 180 into 178 upon 2. So now we can solve this equation. Obviously answer will be less than 760 because there is a relative lowering in vapor pressure. So all answers are less than 760, but there will not be too much decrease in vapor pressure. Very small decrease in vapor pressure. So on solving you will get option B as correct, 752.4. Torr. So if we make this assumption, this temperature is 100 degrees Celsius, then only we can answer this question. Otherwise, we can't answer this question. At 100 degrees Celsius, P naught is equals to 760 torr. So this is our assumption to answer this question. So it's little level of difficulty. You have to think in this way. Next come to the question number 10. Now in question number 10, the question is based on some distillation technique. The distillation technique most suited for separating glycerol from spent lye in the soap industry is. Now you have a mixture of glycerol and soap. So soap is an ionic compound. So this ionic compound have high boiling point, and glycerol is also a trihydroxy compound. Because of extensive hydrogen bonding, its boiling point is also very high. Roughly you can say 290 degrees Celsius is the boiling point of glycerol. Now whenever we have to separate two compounds having high boiling point, we can't use simple technique of distillation, because very high boiling point will get decompose them during distillation process. So for such cases we will use distillation under reduced pressure. So to separate a mixture of glycerol from spent lye, we will prefer distillation under reduced pressure. Simple technique of distillation cannot be used. Steam distillation is used for steam volatile substances, and compounds having intramolecular hydrogen bonding are steam volatile substance. So here there is no possibility of steam distillation. Simple distillation and fractional distillation. Simple distillation is not preferred when boiling points are too high. Simple distillation is preferred when there is a large difference in boiling point of two compounds, and compounds should have low boiling points. Fractional distillation is preferred when two compounds have much difference in boiling point. So when boiling point of substance is very high and substance get decomposed at or below their boiling point on heating, then we prefer distillation under reduced pressure for separation of compound. So again, it is a what we can say a knowledge based question, so moderate level of difficulty. Next come to the question number 11. So it's a question from bonding, very easy question. The species in which the nitrogen atom is in a state of sp hybridization. Sp hybridization means linear nitrogen atom होना चाहिए हमारे पास में. So sp hybridization, you know that in option 1 it is given NO2 minus. So in NO2 minus, central atom is nitrogen. So around this nitrogen there are total 3 electron pair, NO2 double bond minus and lone pair of electron. So its hybridization state is sp2. In second one NO3 minus, so it is double bond minus and coordinate bond O. So it is sp2 hybridized. And in NO there is an odd electron species. So this is single electron is also present in an hybrid orbital. So it is sp2 hybridized, and NO plus is linear because of positive charge on central nitrogen atom. So it is sp hybridized. So it's an easy question based on your knowledge of bonding. Next come to the question number 12. Question number 12 is from physical chemistry, chemical kinetics. Now, question says, the composition of H2O2 follows a first order reaction. In 50 minutes, the concentration of H2O2 decreases from 0.5 to 0.125 molar in one such decomposition. When the concentration of H2O2 reaches 0.05 molar, the rate of formation of O2 will be. Rate of formation of O2 will be, we have to identify. So these questions involve some calculations. Here we can say decomposition of H2O2 as given in question follows first order kinetics. So it is H2O2 on decomposition form H2O and half O2. So here rate of disappearance of H2O2 can be related with the rate of appearance of O2. So rate of appearance of O2 is half of the rate of disappearance of H2O2. So we have to find out the rate of disappearance, rate of formation of O2. The rate of formation of O2 is dO2 by dt is equals to half of rate of disappearance of H2O2. And rate of disappearance of H2O2 can be written as a rate of reaction, and rate of reaction can be written as K into concentration of H2O2. It is first order kinetics. So we have to find out the mainly rate constant of this reaction, and according to this question, concentration of H2O2 decreases from 0.5 at time t equals to 0 to 0.125 moles per liter in 50 minutes. So here we can say it is just there are two half-lives. These are two half-lives. In first half-life, concentration will become 0.25 molar, and in second half-life, concentration will become half of 0.25 molar. So there are two half-lives. So we can say K of any reaction is 0.693 by T half. So when 50 minutes are the time of two half-life, so K will become 0.693 upon 25 per minute, because 50 minutes is the time of two half-life. So one half-life is equal to the 25 minutes. So now we can find out the rate of formation of O2. So half of 0.693 upon 25 sorry, and concentration of H2O2 is 0.05. So on solving, we will get correct answers, and this will be option A, 6.93 into 10 to the power minus 4 moles per liter. So this question required little bit interrelated. First we have to relate rate of disappearance of H2O2 with the rate of formation of O2, and then we have to find out the value of K by considering this time, and then we will have to substitute the value of K to get the answer. So it's a difficult question. It required some time. Next, move to question number 13. Now question number 13 is from coordination compounds. The pairs having the same magnetic moment is the value of magnetic moment. So for the same value of magnetic moment, we have to find out a compound having same number of unpaired electrons. So here all coordination compounds are given. So if you see the option A, in option A it is given Cr H2O whole 6 2 plus, and H2O is a weak field ligand, so there will not be any pairing of unpaired electron. Just directly we can consider Cr H2O whole 6 and 2 plus. So here we can say it is chromium 2 plus, and electronic configuration of chromium 2 plus is Ar3D4, because chromium is argon 3D5 4s1. So we have to remove 2 electrons, one from 4s and one from 3d, so it will be 3d4. So all these 4 electrons are unpaired, so value of n is 4. In this formula for spin only magnetic moment, under root n into n plus 2 Bohr magneton. Now in this option 1, other ice complex is FeH2O whole 6 Fa 2 plus. So again water is a weak field again. So Fe is in plus 2 state. So its electronic configuration will be Ar 3d6, because for iron electronic configuration is 3d6 4s2. 3d6 4s2. So out of these 3d6 again n is equals to 4, because there are 4 unpaired electrons, and here we can say 1 vacant d orbital and 4 unpaired electrons. Now there is one more complex compound, MnH2O whole 6. Although we got our answer, no need to discuss all this in exam. So answer is option 1. But just for better understanding of concept, we can compare this one. So here manganese in plus 2 state, so its electronic configuration is Ar 3d5, number of unpaired electrons are 5. And we have one more compound, CO Cl4 2 minus. So here cobalt is in 2 plus state. Cobalt in 2 plus state, plus 2 and minus 4, minus 2. So its electronic configuration is Ar3d8. Cobalt is 3d7, 4s2. 3d7, 4s2. So 3d7, here n will be, I think, 3, because these 7 electron, 1, 2, 3, 4, 5, 6 and 7. So there are 3 unpaired electrons. So in option A, both the complexes contain same number of unpaired electron in center of coordination. So its spin only magnetic moment will be same. In option 2, one will have 5 unpaired electron and other one have 4 unpaired electrons. So spin only magnetic moment will not be same. In option 3, again one have 3 unpaired electron and other have 4 unpaired electron. So not same value of spin only magnetic moment. And question option 4, one contain 4 unpaired electron and other contain 3 unpaired electron. So the best choice is 1. So it's little bit time consuming question. So answer moderate level of difficulty. Next come to the question number 14. Now question number 14 is based on R and S configuration. R and S configuration. A compound is given. We have to identify the configuration of chiral carbon atom. So for R and S configuration, let's say this is the structure of compound given. First of all, we try to find out the electronic configuration of this chiral carbon atom. This is the second chiral carbon atom. On naming, this will be the order of numbering, because COOH is the principal functional group. So for this chiral carbon atom, we can consider this type of arrangement. Let's say the entire group is some group G. So in group G, or just we can represent G as a, this is CH and Cl and CS3. So now we have to identify the priority of these 4 substituents directly attached from this chiral carbon atom. So the first priority is given to this oxygen. Priorities are based on atomic number of directly attached atoms. Higher is the atomic number, higher is the priority. Here the first atom is oxygen, here first atom is carbon, here first atom is hydrogen, here first atom is carbon. So the atomic number of oxygen is maximum. Now for these two, first atom is same, here carbon and here carbon. Here second atom is oxygen, here second atom is chlorine. So atomic number of second atom is higher, so it will be of second priority, and this will be of third priority, and this will be of fourth priority. Now subsequent of fourth priority, if on horizontal line, then for clockwise arrangement of priority sequence represent S configuration, and anti-clockwise arrangement represent R configuration. Now listen carefully. If subsequent of lowest priority is on horizontal line, then clockwise arrangement represent S and anti-clockwise arrangement represent R. So here the order of 1, 2, 3 is clockwise. So order of 1, 2, 3 is clockwise, so it is S configuration. Now similarly, we can identify configuration of third chiral carbon atom. So we can say this is the some group G dash, and this is hydrogen, this is Cl, and this is CS3. Now again we have to assign priorities. So this is the first priority, this is second priority, this is third priority, and this is fourth priority. Now the subsequent of lowest priority is on horizontal line, and sequence of priority is 1, 2, 3 is anti-clockwise. So for anti-clockwise and lowest priority subsequent is on horizontal, it is R. So we can say 2S and 3R is the configuration of this subsequent. 2S and 3R. 2S and 3R. 2S and 3R is given in option 1. So it is the correct answer for option 1. So we will rank this question in difficult category because it is an out of syllabus. Nothing is mentioned about the R and S nomenclature of optical isomers. So you may or may not know this concept. Next come to the question number 15. Question number 15 is again from physical chemistry. The equilibrium constant at 298 Kelvin for a reaction A plus B in dynamic equilibrium with C plus D is 100. Equilibrium constant is given. If the initial concentration of all the 4 species were 1 molar each, then equilibrium concentration of D in moles per liter will be. Now you know that in question 15, a reversible reaction is given, A plus B in dynamic equilibrium with C and D, and let's say its equilibrium constant Q is 100. Now the value of equilibrium constant is very high, so at equilibrium concentration, the concentration of product will be very high, because the equilibrium mostly remains shifted towards product side if the value of equilibrium constant is greater than 1, and equilibrium remains shifted towards backward direction, that is reactant, if equilibrium constant is less than 1. So it's initially the concentration of D is 1 mole per liter, and at equilibrium its concentration will be greater than 1, because obviously it shifts toward forward direction, the equilibrium constant is very high. So initially at time t equals to 0, this is 1 moles per liter, 1 moles per liter, 1 moles per liter, 1 moles per liter. So we can say Q of this reaction is 1, and Q is less than K equilibrium. So equilibrium shift toward forward direction. When it shift toward forward direction, so at equilibrium, let's say concentration decreases by X to attain this equilibrium. So this will be the new situation. And you know that this reaction Equilibrium constant for this reaction is very high. So we can say this reaction is almost complete. Almost complete, not exactly complete. If it is almost complete, then we can say the concentration of either A or B or both of them is nearly equal to 0. So X is very close to 1. It's not 1, but it is very close to 1. So very close to 1. So the concentration of D at equilibrium is greater than 1 but less than 2. Greater than 1 but less than 2. And we have two such options. And we have to pick up the option which is very close to 2. So it's option 2 is very close to 1.818, or we can just solve it. So 100 is equals to 1 plus x into 1 plus x upon 1 minus x into 1 minus x. On solving you will get x and substitute the value of x here to get the concentration of D. Otherwise, logically we can say equilibrium constant of this reaction is very high, so this equilibrium remains shifted towards product side, and concentration of reactant at equilibrium is very, very less. Whenever you find any situation in which equilibrium constant is very, very greater than 1, you can say whatever is the limiting reagent in reactant, its concentration will become approximately equal to 0 at equilibrium. Thus we can use this trick to answer these questions. So X is very close to 1. So it's again question number 15 is a moderate type question. Little bit understanding, little bit calculation is required. Next come to the question number 16. Question number 16 is very easy, based on metallurgy. Which one of the following ores is best concentrated by froth flotation method? You know that froth flotation method is used for concentration of sulfide ores, except sulfides of silver. So the most abundant common sulfide is galena, zinc blende, etc. So question number 16 is directly option 2 is correct, galena. Option 1 is siderite, which is FeCO3, a carbonate ore. Galena is a sulfide ore, and malachite is a basic carbonate of copper, and magnetite is ferric oxide, a mixture of ferrous oxide and ferric oxide, that is Fe3O4. So for 16th question, answer 2 is the correct. Next come to the question number 17. Question number 17 is based on gas eudiometry. And in this question, we have to identify molecular formula of the hydrocarbon. The question says, at 300 Kelvin and 1 atmosphere, 15 ml of a gaseous hydrocarbon required 375 ml air containing 20% oxygen by volume for complete combustion. After combustion, the gases occupy 330 ml. Assuming that the water formed is in liquid form and the volumes were measured at the same temperature and pressure, the formula of the hydrocarbon is. Let's say formula of hydrocarbon be CXHY. Formula of hydrocarbon is CXHY, and during combustion with oxygen, all carbon of this hydrocarbon comes out as a carbon dioxide and all hydrogen comes out as water, and that will be in liquid state. So on balancing for oxygen, it will be X plus Y by 4. Now 15 ml of hydrocarbon. So here we will apply Avogadro's hypothesis, that is at constant pressure and temperature, volume is directly proportional to number of moles. At constant pressure and temperature, volume is directly proportional to number of moles. So for complete combustion of 15 ml of hydrocarbon, we need X plus Y by times of 15. And after complete combustion, we will get 15x volume of carbon dioxide. Now, first of all, identify volume of O2. So volume of O2 initially is 20% of the volume of air, which is 375, and it's 20%. So on solving, it comes out to be 75 ml, and volume of N2, because it is the volume of air, volume of N2 will be 300, total volume minus volume of O2. So this nitrogen will remain unused before the combustion as well as after the combustion, and after combustion total volume of gases is given as 330 ml. So if we find out the volume of CO2, then it is the total volume after combustion minus volume of nitrogen gas. So total volume after combustion is 330 ml, and volume of nitrogen will be 300 ml, so it is 30 ml. So volume of CO2 is 30 ml, and as per our calculation, volume of CO2 produced will be 15x. So the equation number 1, 15x equals to 30, so x equals to 2. So x equals to 2. So if we go through the options, no such option is given. No such option is given in this question where x equals to 2. So it is a wrong question. And if we solve for the y, so this is the volume of oxygen is 75 ml and entire oxygen is consumed. So we can say this 2 plus y by 4 into 15 is equals to 75. And on solving this equation for y, you will get the value of y as 12. And again, so as per these data, the formula of hydrocarbon is C2H12, which is not possible. So this question is in fact wrong. So bonus marks was provided in this question. Some data are incomplete, what we can say. Next come to the question number 18, which is from P block, group 15. Question 18, P block from group 15. In this question, we have to identify a pair in which phosphorus atom have a formal oxidation state of +3. You know that the two most important oxidation state of phosphorus are +3 and +5. The compound of phosphorus having +3 oxidation state will have us suffix, and that of compound of phosphorus having +5 oxidation state will have ic suffix. So we have to identify an option in which both the compounds are us type of. So first one is hypophosphorus and hypophosphoric acid. Just leave it because we have to identify both having us suffix. Second, orthophosphorus and hypophosphoric acid. This is wrong. Pyrophosphorus and pyrophosphoric acid. This is also wrong. Orthophosphorus and pyrophosphorus acid. Orthophosphorus and pyrophosphorus acid. So this is the correct option. Orthophosphorus and pyrophosphorus acid. Orthophosphorus acid is H3PO3. H3PO3 is orthophosphorus acid, and H4P2O5 is pyrophosphorus acid. H4P2O5 is pyrophosphorus acid. If we analyze the oxidation state, all these three oxygen atom will have -2 oxidation state, so it -6. So all remaining atom will be +6. And in this +6, +3 is due to these three hydrogen atom. So this phosphorus will be in +3 state. Hydrogen is in +1 state. Now here we can say all these 5 oxygen atom are in -2 state, so it is -10. So remaining all atom will responsible for +10. And out of plus 10, all these 4 hydrogen atoms are in plus 1 state, so they contribute plus 4 total. So both of the phosphorus will carry plus 6 charge. So every phosphorus will carry plus 3 charge. So oxidation state of phosphorus in pyrophosphorus acid is plus 3 and orthophosphorus acid is plus 3. So it is an easy question. Next come to question number 19. Question number 19 is from coordination chemistry, and in this question, which one of the following complexes shows optical isomerism? Optical isomerism. And for complexes, we have to identify whether a given complex is dissymmetric or not. And for a complex compound to be dissymmetric, it should not have plane of symmetry or center of symmetry. So in most of the cases, just we can check the presence of plane of symmetry. So in question number 19, option A is cis COCN whole twice Cl2 Cl. So if we draw the structural formula for this complex having coordination number 6, so it is cobalt plus 3. It is in cis form, so cis arrangement is because of arrangement of Cl. So we can say one of the ethylene diamine as at this cis position, another one is at this cis position. So this is the Cl and this is Cl. In this complex there is no plane of symmetry. There is no plane of symmetry, so it is optically active. So we got our answer. Just check second, third and fourth also. So it is trans. In trans, you know that there may be some symmetry. So it is trans because of arrangement of Cl. So this ethylene diamine ligand is always on cis position. So in this compound there is plane of symmetry. This horizontal plane is plane of symmetry. So it is optically inactive. And in CONH3 whole 4 Cl2, again we can draw cis as well as trans. So cis and trans both will have plane of symmetry. Because we can relate like these 4 NH2s represent NH3. So these 4 NH2s represent NH3, so it's the same thing. In cis, just remove these lines and draw NH3, 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 NH3. Just remove these line of CS2, CS2 and draw NH3, NH3. So in option 3, cis as well as trans both will be optically inactive. And in option 4, this compound can exist. So cis and trans both are optically inactive. So this complex exists as a FAC and MER type isomer. And FAC and MER both are optically inactive due to plane of symmetry. So you can notice this plane passing in between these two Cl is a plane of symmetry. And here we can say this plane passing through this is a plane of symmetry. So in question number 19, correct option is 1. So you must make some tricks to identify which is optically active, which is optically inactive. Next come to question number 20. Question number 20 is from B block. The reaction of zinc with dilute and concentrated nitric acid respectively produce. You know that concentrated nitric acid acts as an oxidizing agent and dilute nitric acid also acts as an oxidizing agent. And during their behavior as an oxidizing agent, the product formed are different because of the difference in concentration. You know that with dilute nitric acid, mostly we get NO and N2O in case of metal is zinc. So NO in other cases and N2O in case of zinc. And with concentrated nitric acid, we always get NO2. With concentrated nitric acid, we always get NO2. This is sure. If somebody don't know what will be the product with dilute nitric acid in case of zinc. So here options are such that if you know that with concentrated nitric acid, with any metal, nitric acid will get reduced to NO2, and in only one option there is NO2 with concentrated nitric acid. In first option it is NO, in second it is N2O, in third it is again N2O, and in fourth option with concentrated nitric acid product is mentioned as a NO2. So just because of this knowledge you can answer this question. Even there is no requirement of second information, what will form when dilute nitric acid reacts with zinc. So this is question number 20. Again, very easy questions, and this behavior of nitric acid is very important. You must revise time to time. Next come to question number 21. Question number 21 is from hydrogen. Which one of the following statements about water is false? We have to identify the false statement. False statement about water. Statement 1 says water can act both as an acid and as a base. Yes, water can act as both because water can donate an H plus ion or it can accept an H plus ion. So water can act as a Bronsted acid, that is H plus ion donor, and Bronsted base, that is H plus ion acceptor. So statement 1 is correct, it is not false. Statement 2 says that there is extensive intramolecular hydrogen bonding in the condensed phase. Now, what is the condensed phase of water? Ice. In ice, there is hydrogen bonding, but not intramolecular hydrogen bonding. In ice, there is intermolecular hydrogen bonding. So the option 2 is incorrect, option false. We got our answer. Good. Now, if we consider 3 and 4th, obviously these will be the correct statement. So just ice formed by heavy water sinks in normal water. The density of heavy water is more than that of water, normal water. So density of heavy water is more than that of normal water, and because of this it is called as heavy water. So obviously ice formed by heavy water will sink in normal water. Water is oxidized to oxygen during photosynthesis. It's a very good information. During photosynthesis, you know what happened? Carbon dioxide combined with water in presence of light and chlorophyll pigment, glucose and oxygen is formed. Glucose and oxygen is formed. So reaction is 6CO2 plus 6H2O in presence of light and chlorophyll. We get C6H12O6 plus O2. C6H12 plus O2. So here we can say these hydrogen atoms are removed from water. So removal of hydrogen is oxidation. So water is oxidized to oxygen during photosynthesis. For question number 21, option 2 is the answer as a false statement for water. So it's an easy question. One question is asked every year in JEE Mains from chapter hydrogen. So it's very important. Either it is based on hardness of water, some properties of water, some properties of hydrogen gas, or some properties of H2O2. Next come to question number 22. Question number 22 is again a knowledge based question. The concentration of fluoride, lead, nitrate and iron in a water sample from an underground lake was found to be 1000 ppb, 40 ppb and 100 ppm and 0.2 ppm respectively. This water is unsuitable for drinking due to high concentration of. Now again it is from environmental chemistry. You must have knowledge of various pollutant and various substances present in water. Now if anybody have knowledge of the concentration of these ions in drinking water as a permissible level, permissible limit, then only you can answer. So you know that in water the permissible concentration of nitrate is 50 ppm. It is again based on knowledge. You can't apply any concept, so you will get your answer. So permissible limit of nitrate ion in water is 50 ppm, and in this sample it is given 100 ppm. So it is the not suitable for drinking because of high concentration of nitrate. So for question number 22, option 2 is correct. So I will mark this question as a difficult, because if you have knowledge then it will be easy, otherwise it is difficult for you to answer these questions. Next come to question number 23. In question number 23, the main oxides formed on combustion of lithium, sodium and potassium in excess of air. You know that all group 1 metals form different type of oxides when react with air. Lithium mainly form oxides, sodium mainly form peroxide, and potassium, rubidium and cesium mainly form superoxides. So we have to identify lithium oxide, sodium peroxide and potassium superoxide. So Li2O, Na2O2 and KO2. So option 3 is the correct answers. Next come to question number 24. Question number 24 is from biomolecules. Thiol group is present in. Thiol group is present in. Now here some amino acids are given and we have to identify in which compound thiol group is present. It's not necessary all of them are amino acids. Now we know that thiol is SH. SH group is called as thiol group. So this thiol group is present in. Now we are familiar with cysteine. Cysteine is a sulfur containing amino acid, and methionine is also a sulfur containing amino acid. You know that the structural formula of amino acid is RCHNH2 COOH. Now for cysteine, R group is SHCS2, and for methionine this R group is its ether CS3 S. Other compounds do not contain sulfur. So for question number 24, again it is a knowledge based question. Some structures are mentioned in biomolecules chapter. So for question number 24, it is cysteine, because I remember cysteine and methionine are two sulfur containing amino acids. Sulfur containing amino acids, and cysteine contain SH group, so which is a thiol group similar to alcohol group. So this is question number 24. Next come to the question number 25. It's very easy question. Galvanization is applying a coating of zinc to prevent iron from rusting. Very easy question. Next come to the question number 26. Which of the following atoms has the highest first ionization energy? Highest first ionization energy. Now see, sodium, potassium and rubidium all are the group 1 metal, and group 1 metal atoms have comparatively lower ionization energies. Clear? And scandium is a D block element. So the ionization energy of D block elements is more than that of corresponding S block elements. So correct answer for question number 26 is scandium. Question number 27. In the Hofmann-bromamide degradation reaction, the number of moles of NaOH and Br2 used per mole of amine produced are. Now this question is based on concept of balancing. We rarely use balanced chemical equation in organic chemistry. We just directly write like this is the amide RCONH2 reacts with Br2 and NaOH to form product RNH2. So just we have to balance it. So RCONH2 plus Br2 plus NaOH. So you know that product is RNH2. So we have to remove this CO from this molecule, and CO will be removed as some sodium salt, so which is Na2CO3, and this Br2 will also be removed as sodium bromide, NaBr. So we need 4 moles of sodium hydroxide, 2 moles to remove bromine as a bromide, and 2 moles to remove this C as a carbonate. And to balance hydrogen, here there are the 4 extra hydrogen atoms, so we will add 2 H2O. So we have 4 oxygen, 4 sodium, 4 and 6 hydrogen, 4 and 6 hydrogen, 2 bromine, 2 bromine. So this is the balance equation. So what we have to find out, how many moles of NaOH and Br2 used per mole of amine produced. So per mole of amine produced, 4 moles of NaOH and 1 mole of Br2 are used. 4 moles of NaOH and 1 mole of Br2. So option number 3 is the correct answer for this question. Now in question number 28, some calculations are required. Read this question. 2 closed bulbs of equal volume containing an ideal gas initially at pressure Pi and temperature P1 and temperature T1 are connected through a narrow tube of negligible volume as shown in the figure below. The temperature of one of the bulbs is then raised to T2. The final pressure is. What we will do? We can apply ideal gas equation. Now, initially, just find out the number of moles of ideal gas in these 2 bulbs. Number of moles of ideal gas in these 2 bulbs. And then number of moles of ideal gas will remain same because just we are heating. So on heating, volume is constant. So on heating, pressure will get changed. Pressure will get changed. So this is bulb 1, P1 and some volume V. This is bulb 2, P1 and some volume V. Temperature is T1 and temperature is T1. So here we can say number of moles is N1 and here N1. So total number of moles in this situation will become twice of P1 V by RT1. This is the total number of moles. Now temperature of one of the bulb is changed from T1 to T2. So its pressure become final pressure P final, and this is volume, and temperature is T2. So just find out the number of moles in these 2 bulbs and then add them because we know the total number of moles initially. So here let it be N and it will be N dash. N is equals to P final V by RT1 and N dash is equals to P final V by RT2 and NT is equals to N plus N dash. So it is 2 P1V by RT1 is equals to P final V by RT1 plus P final V by RT2 so we can say this can be written as P final V by R 1 by T1 plus 1 by T2. So volume is same. So this V and this V will cancel out. This R and this R will cancel out. Okay. And we have to find out the value of final pressure. We have to find out the value of final pressure, or we can write this as a P final into T2 plus T1 upon T1 T2. P final T2 plus T1 upon T1 T2. So P final is equals to twice of P1 into T2 T1 T2 upon T2 plus T1 upon this T1. So this is the P final, 2 P1 T1. So this T1 T2 T1 T2. And this T1 will cancel out, and finally it will be 2P1 T2 2P1 T2 upon T1 plus T2. So option 2 is correct. Option 2 is correct. Some calculation is required, otherwise it is an easy question. Next come to question number 29. The reaction of propene with HOCl proceeds through the intermediate. Reaction of propene with HOCl proceed through the intermediate. You know that propene is an alkene, and alkene whenever react with polar reagent undergoes electrophilic addition reaction. First there is attack of positive part, electrophilic part of the attacking reagent, and in this electrophile the positive part of attacking reagent is Cl2 in water. So positive part is Cl. So this is propene. When react with HOCl, so we can visualize HOCl as this compound. So during inductive effect of CS3, this electron will move in this direction, and this electron pair will comes out, and we will get CS3, CH, CH2, Cl and plus, and there will be attack of H2O or OH. So this intermediate is given in option A, CH3, CH plus, CH2, Cl. Or actually we can say the actual intermediate that form in these reactions is cyclic haloniamine, but such type of option is not given, so we will prefer this one. Otherwise, this is the actual intermediate that form in this reaction. So this is question number 29, easy type question. Next come to question number 30. And question number 30, there is some correction in question itself. So I am just drawing actual figure. The actual figure is in first it is treated with NBS in presence of light, and in second it is treated with H2O and K2CO3, and we have to identify product X. You know that NBS is used for allylic bromination. So one of the allylic hydrogen atom of this compound will displace by bromine, and this H2O in K2CO3 aqueous solution is alkaline. Aqueous solution of K2CO3 is alkaline because it is a salt made up of strong base and weak acid. An aqueous solution of such type of salt is alkaline. So this alkaline solution provide OH minus. So first what happened? Okay, this is an allylic system, and in this allylic system, during reaction with NBS, there is a displacement of allylic hydrogen by bromine, and then allylic bromine will displace by OH. So ultimately, we have to identify a compound in which OH group is placed on allylic position of this substrate. So these are the allylic positions. So just find out an allylic alcohol from the option. So option A1 is allylic alcohol, option 2 is alpha beta unsaturated ketone, option 3 is again an beta gamma unsaturated carboxylic acid, and option 4 is just the original starting reactant. You got? No need to solve it. Just think, first there will be an introduction of bromine into the substrate, and then there is a substitution of bromine by OH group. So ultimately we will get a hydroxide. So this question may looks very difficult, but it's a very easy. So in this way we complete our discussion. So I hope you have made a list of various concepts and again revise these concepts. So ultimately these topics will become stronger for JEE Mains 2017. Thank you very much.